I'm Kira.
I'm Katie.
I'm Julia.
I'm Seth.
And this is Calculus Cooking for Mr. Cook. And today we're making
Oreo chocolate chip cheesecake cookie bars.
We're going to be presenting the recipe to you all in calculus problems. The first ingredient in our recipe is cookie dough, and so for that,
we're going to assess to solve the problem of how much cookie dough we need.
So distance equals area under the curve. So if we wanted to find the area of one of these regions, it would be 1/2 base, which is 1, times height, which is 2. And we want to multiply that by 4 because there's 4 regions. And that would give us 4. So the final position would be the initial position plus 4. And in the problem, it's given that it starts at 2. So it'd be 2 plus 4. So that'd be 6. So we need 6 cups of...
Now we're going to be spreading the 6 cups of cookie dough in a 9-inch by 13-inch pan.
After you've layered the pan about 1 centimeter thick with cookie dough, you're going to have some left over. Just set that aside for later.
Alright, so to make the cheesecake part of this recipe, the first thing that we need to do is find out how much cream cheese we need to use. For that, let's head to a set.
So the slope of the tangent line is the derivative of f of x. So the derivative of f of x is -1. And if you wanted the slope of the normal line, that would be -1 over f of x, and that would give you 1. So you want one package of...
So it looks like we need 1 pack of cream cheese. While Kira's adding in the cream cheese, it looks like our next ingredient is sugar. So for this next problem, let's head over to Julia to see how much sugar that we need.
So the general function for the inverse of the derivative of f of x is 1 over f prime y. So f prime of x in this problem is 3x squared minus 1. So if we plug that into this general formula here, we get 1 over 3y squared minus 1. So since x in function land is y in inverse land, we're going to plug 1 into our equation as y. So we would get the derivative of the inverse of f of 2 is equal to 1 over 3 times 1 squared minus 1, or 1/2. So that means that we need 1/2 cups of sugar in our recipe.
Thanks, Julia. Okay, we'll go ahead and add a 1/2 cup of sugar.
Asaf, how many eggs do we need?
So given this general equation for the average value, you'd go 1 over 9 minus 1 times the integral from 1 to 9 of 1/2 x squared dx. So then you want to anti-differentiate. So the antiderivative of 1/2 x squared is x. So then you have 9 to 1. So you want to plug in 9 minus 1. So you get 1/8 times 9 minus 1, which would give you 1. So you want...
And it looks like we're going to need 1 egg.
The next ingredient is vanilla. For this, we're going to have to flash over to Julia for another problem.
Okay, so first we have to recognize that x equals 2 is not in the domain. And to find the local maximum, we know it's going to be at any one of the critical numbers in this equation. So we need to find the critical numbers, which occur when the derivative of f of x is equal to 0 or undefined. So to find the derivative of f of x, we need to use the quotient rule. So that's going to be low d high, x minus 2, and then the derivative of the numerator, which is 4x minus 3, and then minus high d low. And since the derivative of the denominator is 1, it's just going to end up being the numerator. And then all over low squared, x minus 2 squared. And then we're going to simplify this with some algebra. Okay, so now that we've done some algebra and we've simplified the equation, we've found that the critical numbers occur when x equals 3, 1, and 2. Except 2 is not in the domain, but we're still going to consider it on our number line. So we have 1, 2, and 3. And when we plug these numbers into the derivative, we're going to find that the derivative of f of x is going to be positive at any number before 1, negative in between 1 and 3, and then positive again after 3. So if we draw our little slope arrows, we're going to find that the maximum occurs at x equals 1. So we need 1 teaspoon of vanilla in our recipe.
Thanks, Julia. We'll go ahead and add 1 teaspoon of vanilla. The next step is to go ahead and stir the mixture until you have no lumps. So the next thing you're going to do is pour it onto your mixture. When you pour it, make sure that you do so evenly across the cookie dough mixture.
And now we're going to sprinkle the remaining cookie dough on the cheesecake layer.
The next step is to put the product in the oven at 350 degrees for 20 minutes. Make sure to set a timer so that you know what time to take it out. After 20 minutes, go ahead and take the product out of the oven. Make sure that you wear enough gloves so that you don't burn yourself. The last thing that we need to add onto this dessert is a chocolatey glaze.
And our first ingredient in the chocolatey glaze is white chocolate chips. Hey Katie, what is the amount of chocolate chips that we need?
I'm not exactly sure, but let's head over to Asaf to find out.
Okay, so for this problem, you're going to want to use L'Hopital's rule. So you have the ln of 2 plus e to the x over 4x. So if you plug in infinity here, you still get positive infinity. And then multiplying by a constant won't change anything, so you still have positive infinity. So you have an indeterminate form. So now you could take the derivative of the top and the bottom. So you have the limit as x approaches positive infinity of e to the x over 2 plus e to the x over 4. And then you could rewrite that as the limit as x approaches positive infinity of e to the x over 8 plus 4e to the x. So then if you plug infinity into here, you still get infinity over infinity, which is another indeterminate form. So then you take the derivative of that again. So you get the limit as x approaches positive infinity of e to the x over 4 e to the x. And then that could be rewritten as the limit as x approaches positive infinity of 1 over 4 because the e to the x's cancel out. And then you would get 1/4. So you need 1/4 cups of white chocolate chips.
Thanks, Steph. We'll go ahead and add those in. The next thing we need to add is dark chocolate chips. Julia, how many do we need?
Okay, so this is the graph of secant x, and we're only interested in the area between x equals negative pi over 4 and pi over 4. So that's really only this little area right here. And we're going to use the disk method to revolve the solid around the x-axis. And so the general equation for using the disk method is volume equals pi from the integral of a to b f of x squared dx. So we're going to plug in our numbers. So volume equals pi, and our a is negative pi over 4, and our b is pi over 4. And then f of x is secant x, and since it's squared, we're going to do secant squared x dx. And this works out really well because we already know the antiderivative of secant squared x is tangent x. So we're going to look at tangent x from pi over 4 and negative pi over 4 at the bottom, all times pi, and that's going to give us our volume. So we're going to plug in these values here and get pi times the tangent of pi over 4 minus the tangent of negative pi over 4, and that is going to give us pi times 1 plus 1, which equals 2 pi. So if we plug that into our calculator, we're going to get 6.283 ongoing. And if we round that to the nearest whole number, we're going to get 6. So we need 6 tablespoons of dark chocolate chips in our recipe.
Thanks, Julia. So now we're going to add the 6 tablespoons of chocolate chips, and we also need to add shortening. Hey, Julia, how much shortening do we need?
Okay, so for this problem, we need to use L'Hopital's rule. So first, we're going to put it into fraction form so that we can find an indeterminate form. So the limit as x approaches positive infinity of e to the 2 over x minus 1 over 1 over x, and that is equal to 0 over 0, because e to the 0 is 1, minus 1 equals 0, and then 1 over a huge number is going to be equal to 0, and this is an indeterminate form. So now we're going to find the derivative of both the numerator and the denominator. So this is going to end up being the limit as x approaches positive infinity of e to the 2x times negative 2 over x squared, all over negative 1 over x squared. And then the x squareds cancel out, the negatives cancel out, and you get left with the limit as x goes to positive infinity of 2e to the 2 over x. And if you calculate that out, it's going to end up being 2, because this ends up all being 1 times 2 is 2. So you need 2 tablespoons of shortening in the recipe.
Thank you. Okay, so we're going to go ahead and add 2 tablespoons of shortening to our little glaze. The next thing we're going to add is Oreo cookie crumbs. How many do we need, Julia?
Okay, so first we're going to find the derivative of f of c, which is going to be 3c squared, over the derivative of g of c, which is going to be 2c minus 1, and then that all equal to, and then we're just going to plug in a and b for the numbers here. So it's going to end up being 1 cubed plus 1 minus negative 1 cubed plus 1 over 1 squared minus 1 minus negative 1 squared minus 1. And then we're going to do some, okay, so after we did some algebra, we ended up with this quadratic equation. So if we factor that out, we're going to get 3c minus 1 times c plus 1 equals 0. So our possible values of c include 1/3 and negative 1. And we know our amount is not going to be negative, so we know the answer is 1/3, and we are going to have 1/3 cups of cookie crumbs in our recipe.
Thanks, Julia. So now we're going to add a 1/3 cup of Oreos into the mixture.
Now the last step for our glaze is to go ahead and heat it up. So you're going to heat it for 30 seconds, take it out, stir it, and then put it back in for another 15, and your glaze will be good to go.
So now we're just going to mix.
And when you're done mixing, go ahead and put it back in for another 10 seconds. This is the final stir. When you're done stirring, you can go ahead and drizzle it on top of your now finished product.
Thank you so much for joining us on Calculus Cooking for Mr. Cook.